Hello everyone, my name is Vasishta. I am from Group 365. Today I am going to discuss about the fruit plucking drone. The main overview of the project is to detect the fruits from the orchards and make it a systematic manner to give the farmers a benefitable uh, thing. Here, coming to the business case, the cost is reduced from the labors by not depending on the labors or any other wages, and the efficiency can be increased by uh, automating the fruit plucking with the harvesting process, gathering, and the yield can be optimized effectively. The main users can be advanced by the farmers who can be uh, gain their productivity and reduce their costs, and the ripening fruits can be detected by the drones and they are segregated and they have plucked from the trees. So many agri-tech companies uh, commercialize these autonomous harvesting solutions, and the input can be given to the system as a live camera feed for real-time fruit detection from the sensor data, and the pre-trained model will detect this and give the output as bounding boxes with detector and fruit locations, and the drone navigation data will send the coordinates with movement path, and the simulation will target the picking action with success and failure metrics. Drone delivers this fruit to collection points. Coming to the architecture diagram, here the LiDAR and scanner of the depth sensor given to the YOLO model, and it is masked with the RCNN. Then it is given to the robot operating system and simulation. With the help of that, it is operated with the Jetson Nano and Raspberry Pi if we use it, and which consists of 5G and Wi-Fi signals. Then it is given to the mobile application to control it by the farmers. Here we have collected a wide range of data from various websites like Kaggle and RoboFlow Universe to get the dataset of the images. Then the image is normalized and resized to the for better validation and normalizing the standard images and giving some lighting conditions, and also doing some rotations and flips to improve the adjustments of the models. And the AI model trained using the YOLO V8 fine tuning and accuracy for the speed. So the tech stack here is for the front end, we are using HTML, CSS, and JavaScript for the web application to control by the farmers and also by the drone system. For the hardware, there is a micro controller to control the robotic arm and uh, the drone system. For the backend, this YOLO model and the drone control system simulation are running, and for the deployment, we are doing it in the cloud deployment for better capability of the farmers. Thank you.